Hi, this is Mr. Manley. In this video, we're going to look at simplifying powers of I, which is building upon our understanding of I squared. So we are introduced to I, which we know is equivalent to the square root of -1. And then we went to I squared, right? And we said I squared is equal to -1. And we've used that, or you have used that in some of your work with imaginary numbers, operating with imaginary numbers. Now I'm going to keep going here. How about I cubed? Using the laws of exponents, I could say that I cubed is I squared times I. And I squared, I just set up above, is -1. So that's -I. So I can simplify I cubed to -I. What we're going to find out is that every power of I is some combination of these two, I and I squared. So let's continue. If I go I to the fourth, what is that? That is I squared times I squared. And I said that I squared is -1. So that's -1 times -1, which is +1. Let's continue. I to the fifth. How would you split that up? What do you think? Well, I'm going to break it up into I to the fourth times I. Well, I know from above that I to the fourth is 1, so that's 1 times I. And then I to the sixth, I'll break that up into I to the fourth times I squared. I to the fourth, I know is 1. I squared, I know is -1. So that's 1 times -1, which is -1. I to the seventh is I to the fourth times I to the third. Well, I to the fourth is 1. I cubed, I saw up here is -I. So that's 1 times -I. -I. And then I to the eighth is I to the fourth times I to the fourth, which is 1 times 1, or 1. Now look at this pattern here. If I go, I'm starting off at I, -1, -I, 1. I, -1, -I, 1. And that's the pattern. And it just continues for all powers of I. So let's look. If I looked at I to the 33rd, can you think of how you could rewrite that as, well, what could I do? I mean, I could do I to the fourth times I to the fourth times I to the fourth. Well, how many of those are there? One way of finding out is dividing by 4. So if I take 33 and I divide by 4, what is that, 8? And then a remainder of 1. So I can rewrite this using that 8 and remainder of 1. I can rewrite this as 8 to the fourth to the eighth times I to the first. I don't know, did I say that right? I to the fourth to the eighth times I to the first. Okay, now evaluate that. Well, what's I to the fourth? That's 1 to the eighth times I. So it's I. Let's look at I to the, say, 96. How could I write that? All right, I'm going to do 96 divided by 4. So that is 24. No remainder. So I know that I can write 96 as I to the fourth to the 24th. Do you understand that? By the laws of exponents. By the laws of exponents, a power to a power, multiply. 4 times 24 is 96. So I can rewrite I to the 96 as I to the fourth times, or I to the fourth to the 24th. So what is that? 1 to the 24th, which is 1. So I to the 96 simplifies to 1. Let's just try one more. Say I go I to the 18th. All right? So what do I do? 18 divided by 4, and that's 4, remainder 2. So that means that I can rewrite 18 as I to the 4th times I squared. You need to follow the relationship. Stop and check it and look at the relationship between dividing the exponent by 4, which tells me how I can rewrite, or how I should rewrite, the power of I. And then I have this really easy expression to evaluate. This really easy expression where I to the 4th is 1 to the 4th, which is 1, times I squared, and I squared is -1. So you can definitely follow this pattern. And you could follow the pattern and use it in a way different than I have, this idea of dividing by 4. You could probably think about it in a different way. But you should definitely stop and look at this initial pattern and understand that that pattern continues with all powers of I. And then I'm saying the way to figure out where you are at in the pattern is to divide the exponent by 4. And then look at the remainder, and the remainder will tell you whether you're at the first position, second, third, or fourth position in the pattern. All right, so that is that understanding, and then that method, but even without the method, your understanding should give you the power to evaluate any power of I.